For the first time in history, a scientist has been given the go-ahead to create life itself.
Who am I? Where did I come from? Why do we exist? What are we made of? I have the phenomenal privilege of being able to answer those questions.
Good evening. I am Alpha and Omega. The beginning and the end was how St. John put it, but now science is poised to create life. The man who wants to conduct the experiment has already been granted approval. Russian troops have killed 3,000 people and created 150,000 refugees. Why don't the Chechens deserve the kind of help Britain swore was an ethical imperative in Kosovo? France is hinting at a compromise in the beef war. Will the government be prepared to meet them halfway?
There seemed to be days when sometimes he would be taken almost every hour into the room and be beaten. I could hear the sound.
And biblical parenting is the newest in Christian America's advice on childcare. But for them, smacking is the only way to remove a young child's guilt. It's become a pretty empty cliche to talk about scientific advances as playing God. The implication is that left to God, children would still be dying of smallpox. Yet for once the phrase seems appropriate. Newsnight has learned that science is about to engineer something which only a few years ago seemed impossible: the creation of life itself. The discovery has enormous implications, scientific and ethical. Our science correspondent Susan Watts has been talking to the people at the forefront of life research.
This is the scientist who's designing life forms that can eat nuclear waste. This is the scientist who's sending microbes into space to see if these tiny organisms could have brought life here. And this is the scientist who thinks he can create life from scratch. They're all trying to find the meaning of life.
They're childlike questions. I think you must have asked yourself these questions. I think everybody on this planet has. Who am I? Where did I come from? Why do we exist? What are we made of? I have the phenomenal privilege of being able to answer those questions.
The scientists are gathering clues to answering those questions from unlikely life forms that survive where they really shouldn't, in the boiling hot springs of Yellowstone Park, the frozen ledges of Antarctica, the impossibly inhospitable salty lagoons of Mexico, and thousands of feet under the sea in the superheated plumes which spew out where the Earth's crusts meet. But this is officially the toughest life form on our planet. Not Michael Daly, but the bacteria in the flask he's putting into a radiation chamber. He's blasting them with 1,000 times more radiation than it takes to kill a human. Enough, in fact, to kill anything on Earth except the bacteria Deinococcus radiodurans.
Let's consider, first of all, Deinococcus that has seen no radiation, and you can see that it's grown fully on this plate. By comparison, E. coli with no radiation grows perfectly well. However, if we subject these cells to just a little bit of radiation, let's say 1,000 rad. 1,000 rad will pretty much kill the E. coli that we've just seen. And certainly 1,000 rad is lethal to the average human.
And what happens if you step that up even further to levels of radiation that nothing else on the planet could survive?
So following an extremely high dose of radiation, comparable to being very close to an atomic blast, you can see that Deinococcus radiodurans survives. And in fact, we find lone survivors extending out to 3 million rad.
News from Oak Ridge, Tennessee is naturally atomic.
For 50 years, America's nuclear bomb production program created a radioactive landscape across vast tracts of the United States, a massive cleanup which will cost at least $300 billion. Now Michael Daly is hoping Deinococcus might be able to help. He's inserting new genes into the bacterium so it can not only degrade toxic chemicals, but maybe even turn the volatile radioactive soup in the waste dumps into rock.
The aim is to detoxify the sites. One would drill holes into the ground, and then one would inject the bacterium. And it would hopefully then degrade the organic toxins and break them down into carbon dioxide and water, and it would transform the metals, which are soluble currently, into minerals and therefore protect groundwater supplies.
The reason we can alter the genes of Deinococcus is down to this man. Craig Venter's just finished decoding all of the DNA that makes Deinococcus what it is. Earlier this week, he revealed on Newsnight how he hopes to decode the entire human genome by next June, far sooner than anyone expected. Now, he's planning the most audacious project in the history of biology, a Genesis experiment.
If you could put a cell together from scratch, from having all the components and ending up with a living cell, from truly understanding the complete molecular basis of life, it would be a phenomenal accomplishment because it would mean that science truly achieved the understanding of biology.
It may sound impossible to create life from scratch, but if anyone can pull it off, Craig Venter can. He's the world's fastest genetic decoder. He's close to decoding the fruit fly. He's already completed the first malaria chromosome and just about finished off cholera.
Nobody wants to work on any species now in science unless the genome has been decoded, because it's like going into a darkened room or a cave and then turning on a light switch. And it's that much difference in terms of what we can do in terms of biology, in our understanding of life.
Scientists have been trying to create life since the 1950s, but it's only since the decoding of genomes that they've started to understand its minimum requirements. Latest estimates suggest humans have as many as 140,000 genes. But Craig Venter's taken mycoplasma, one of the simplest bacteria, and cut back its genes one by one to find the minimum it needs.
We got down to around 300 genes. But the most amazing thing of this, out of 300 genes, 100 of them are totally new to science. We have no idea what they do. So that's where the notion came that if we were going to test that 300 were actually the right number, that we would have to make a synthetic chromosome and try and make a synthetic life form. But we decided before we did that, we would get some ethical input to make sure that it was a reasonable thing to do. So we stopped the experiments at that stage.
Newsnight has learned that he's now received the ethical approval to go far further, to create life from scratch, to restart the clock of evolution, to see how it worked gene by gene. The go-ahead and details of his minimum genome will be published in early December. He won't start, though, until he's finished the human genome and unravelled the chimpanzee to see how we differ. He'll also have to be satisfied there's no chance of bioterrorists misusing his work. When he does begin, will he perhaps recreate that spark of life that must have happened at least once before on Earth? Unless life came from elsewhere in the universe.
Well, we don't know that that hasn't already happened. We don't know that's not how we got here. Life can exist in outer space, so I don't want to be too presumptuous thinking that life originated on this planet and didn't come from elsewhere.
And that's exactly what's being tested, in an experiment to see if bacteria could survive the journey through the cosmos. This is what they're sending into space, these tiny pink life forms that give these salt flats their distinctive red colour. Organisms so specialised they can survive these extreme salty conditions and the rigours of space, making them ideal for ferrying life around the universe. Life on the margins like this is surviving not just the ultra-dry environment of these Californian salt pans, but constant ultraviolet radiation from the sun. It turns out that the planet's most primitive life forms, time capsules of the very early Earth, are perfect candidates for coping with the challenges life would meet if it were travelling through space.
Here we have the actual flight samples. These have been in space for 2 weeks, and they just returned last week. If you look here, here we see a small little disk that flew, and if you look at it carefully, you might be able to see some of the salt crystals on it. And within these salt crystals are the red bacteria, the salt-loving bacteria.
Rocco Mancinelli has just found out that some of the bacteria have survived being left out in open space. He originally found these red and green organisms in the salty lagoons of Mexico, held in minerals called evaporites that build up where the tides wash against the shore.
This evaporite is made up of sodium chloride, table salt, and calcium sulfate. And what you can see here is you can see a green band that forms just beneath the surface of this particular salt crust, and that green band is made up of microorganisms. And if you take it out of this particular evaporite, it will die. Now here we have the second organism that we've been working with, and this particular organism is also a halophile, halophile meaning that it loves salt, and we find it in solid sodium chloride or table salt crystals. And if you can look at this, it might be a little pink, and the pink that's in there is due to the microorganism. And here we have taken them out of the crystal, and we're actually growing them in this solution. And you see that the solution looks a little pinkish or reddish, and that's all due to the microorganism. So these are the two organisms that we're working with and that we're flying in space.
And the world's toughest bacterium is going up next.
The next series of experiments will be on the space station, and it will be on the external platform of the space station. One of the organisms will be Deinococcus radiodurans. They're going to go up on 2001, the 2001 launch, and they will be the very first astrobiology series of experiments on the space station.
So maybe the search for extraterrestrial life should be concentrating their efforts on life here on Earth, rather than listening for radio signals from elsewhere. That search was pioneered by Frank Drake in 1960. For him, genomics has raised the possibility that we might send out our own very personal message to the stars in a radio signal. He's worked out that we could send the entire code for a human being in a transmission just half an hour long. So if a civilization out there were to receive that message, what could they do with it?
Well, if they were sufficiently sophisticated in science, and that means at about our level in molecular biology, they could make a DNA molecule based on our genetic code, which contains all the information of the genetic code. They could then place that in a nurturing medium, presumably a cell, where that molecule would cause the development of a duplicate of us. It's a mind-boggling thought, but it could be an exact duplicate of the human being described by that genetic code.
Michael Daly thinks we could send that code out across the universe in another way, in tiny packets that can stitch themselves together on arrival.
One could put an encoded message into a bacterium such as Deinococcus and send it out on a spaceship and explode it and let the seeds of life go where they may, and hope that someone has the technology to decipher that information billions of years from now. Yeah.
As we approach the third millennium, gene decoding is taking us closer to answers for those childlike questions. What is life? Where did it come from? And even, can we invent new life ourselves?
Oh, there's in the studio now Professor Andrew Lindsay, Fellow of Mansfield College, Oxford. And joining us from Manchester, Professor John Harris is Professor of Bioethics there at the university. Professor Harris, this is either highly exciting or highly worrying. Which do you reckon it is?
Well, I think this is highly exciting. It may well not be the first time that a synthetic chromosome has been made. That has been done already. But I think the possibilities are going to be immense from this, and I think we should be excited by it.
Professor Lindsay, what do you reckon?
I think we should be rather appalled. Actually.
Why?
I think we should be appalled at the political naivety of it all, actually. I think the idea that gaining more and more absolute control over the origins of life, I think that is intrinsically undesirable.
Why?
During the last 100 years, political progress has consisted in freeing ourselves from absolute claims of state or vested interests. And here we are now pursuing a kind of technology that will enable some human beings to decide what other kinds of human beings should live. In other words, to manufacture life in the same way we have been trying to do redesigning animals for many decades.
Professor Harris, what do you make of that argument?
Well, to understand how genes work, to understand how life works, is to be able to repair it when it goes wrong, to be able to cure all sorts of diseases. Any tool can be used for good or for ill, including genetics. What we have to do is to have the courage to first find the knowledge, and then the courage and the resolution to use it appropriately. But the idea that we shouldn't discover things for fear that we won't have the courage to use them decently and humanely seems to me to be absurd.
I'm not saying we shouldn't discover things. Of course, that palpably misrepresents my position. I'm saying we shouldn't seek absolute control over the nature and origins of life. And doing that inevitably means that some human beings will have absolute control over other human beings and the kind of beings that we should be, and the kind of human beings we're allowed to be
I'm unclear
to live.
what this phrase absolute control means.
Well,
what is
You
being
take the
proposed?
words out of my mouth, Professor. I don't know what you're on about either.
Well, well, let me give you an example. I look, for example, at our contemporary use of power over animals. Now, no one who looks at our contemporary exploitation of animals could say anything other than our power has not been benign. We have used our power exploitatively, selfishly. And I think it is simply naive to think that we can allow scientific knowledge to develop in such a way that issues in knowledge that can be used politically.
You come from a particular position on animals.
We all come from a particular position.
Right, and we're sort of familiar with yours. But Professor Harris, I want to ask you this. In this case, these are scientific advances which are being driven by commercial motives, aren't they?
These may well be. I don't think the motives that drive them matter too much. I think what matters is
but surely they do, because what we're interested in is the application. Of course. Okay, go ahead.
If you will let me finish, I'll explain why I don't think they do matter. What matters is that we, each society, and indeed the world community, decide how they are to be permitted to be used. It doesn't matter what's driving them. What matters is how we control them. And nothing that I've said indicates that we shouldn't control them and watch them very carefully. And of course, that's crucial. And we are as familiar with controlling commercial interests as we are with pure scientific interests, or indeed with other sorts of interests.
Is it not the case, though, Professor, that in science, once a thing has been shown to be possible, it has generally speaking been done?
Well, many of the things that have been done should not have been done, and I think we have started, belatedly in some cases, to learn those lessons. The task for human beings is always to decide what is good and try to pursue it, and to decide what is evil and to try to avoid it and to prevent others from pursuing it. But it will be foolish to cut ourselves off from the benefits that science can bring for fear that we won't have the courage to exercise the appropriate controls. This is an exciting technology. It holds out huge prospects for understanding life better so that we can make living better for each and every human being. And it seems to me that our responsibility is to pursue that science and use it responsibly.
Well, you say you know where I'm coming from. Well, I'm coming from a theological background, and I have to say I find Professor Harris's touching faith in humanity may make good television, but it makes appalling politics. What I mean by that is, what has happened to a doctrine of human fallibility? We are greedy, we are wicked, we are violent, we are sinful, heaping up more and more power into the hands of fallible human beings.
You're entitled
to your panacea.
View. Okay, you're entitled to your view about human fallibility or original sin or whatever it is.
Well, highly relevant.
Professor Harris, there is a problem, that is there not, at a practical level, in what mechanisms you can put in place which will possibly control this?
Well, the mechanisms, in a sense, each society already has in place. I mean, our society has very good mechanisms in place. In the United States, slightly less so. But, I mean, the simple mechanism, of course, is laws. We can decide what we will permit. And this is where the problem of commerce that you raised earlier is a problem. We can decide as a society what we will fund, but of course we have less control over what commerce will fund. So the only alternative there is to actually take control through legislation or through regulatory bodies. But I think each society is doing that. In my view, in some cases, rather too strongly.
We're going to have to leave it there, I'm afraid. Thank you both very much.